Module 5 Threat Sharing covers the following: threat sharing platforms, benefits of threat sharing standards, and threat intelligence dissemination and platforms. Upon completion of this module, students will be able to provide subject matter expertise to the development of cyber operations specific indicators, monitor and report on validated threat activities, perform event correlation using information gathered from a variety of sources within the enterprise to gain situational awareness and determine the effectiveness of an observed attack. The threat hunting maturity model is reflected in a 2020 survey conducted by SANS. Roughly a third stated that threat hunting is not mature enough but is currently evolving. Most respondents indicated that they are benefiting from threat hunting. There is very little agreement on threat intelligence best practices in terms of TI definition, the sourcing of TI, and how to implement or make TI actionable. This slide depicts the sourcing of threat intelligence. Roughly 83% is coming from threat hunting personnel and 76% from security operations. Improvements of threat hunting are predominantly on attack surface exposure, network endpoints, and accurate detection systems. Improvements of threat hunting are predominantly on attack surface exposure, network endpoints, and accurate detection systems. Reasons for threat information sharing include the following. Number one, to leverage collective knowledge to fight threats. Number two, to gain a better understanding of the threat landscape. Number three, to be able to make well-informed decisions on detection and mitigation. And number four, to improve threat-related controls, processes, practices, and tools. Types of threat intelligence are the following. Indicators of compromise. These are digital artifacts such as log files or entries, network packet, etc., that identify attacks or threats on a system or network. TTPs. These are nuggets of information from the knowledge base of the MITRE ATT&CK framework. Security alerts may come from intrusion detection or prevention systems. Threat intelligence reports that are produced by reputable entities on the Internet, such as SANS, Cisco, Palo Alto, CrowdStrike, or Dragus. Tool configurations or setting. These are threat information produced by customized threat collection tools. Threat intelligence sharing standards include the following. OpenIOC is an open framework meant for sharing threat intelligence information in a machine-readable format. It was developed by Mandiant in 2010. The Incident Object Description Exchange Format, or IODEF, defines a data representation that provides a framework for sharing information commonly exchanged by computer security incidents response teams about computer security incidents. The Traffic Light Protocol is a system for classifying sensitive information created in the early 2000s by the UK government's National Infrastructure Security Coordination Centre to encourage greater sharing of sensitive information. Open Threat Exchange, or OTX, is a threat data platform that allows security researchers and threat data producers to share research and investigate new threats. OTX provides open access for all, allowing you to collaborate with a worldwide community of threat researchers and security professionals. STIX, or Structured Threat Information Expression, is a standardized XML programming language for conveying data about a cybersecurity threat in a common language that can be easily understood by humans and security technologies. Trusted Automated Exchange of Intelligence Information, or TAXI, defines how cyber threat information can be shared via services and message exchanges. It is designed specifically to support STIX information, which it does by defining an API that aligns with common sharing models. Cybox is a standardized language for representing cyber observables, whether dynamic events or stateful properties that are observable in the operational cyber domain. The Collective Intelligence Framework is a cyber threat intelligence management system. It allows you to combine known malicious threat information from many sources and use that information for identification, detection, and mitigation. MISP Threat Sharing is an open source threat intelligence platform. The project develops utilities and documentation for more effective threat intelligence by sharing indicators of compromise. In STIX, domain objects representing concepts in the cyber domain and used to describe things are related to each other using STIX relationship objects. This slide depicts the STIX objects. Each of these objects has certain attributes that fully define itself. Notably missing in this diagram are the lines connecting the object with each other, indicating their relationship with each other. This slide depicts a network traffic object with attributes such as IPv4 addresses, protocol types, and others. A trusted automated exchange intelligence information, or TAXI, defines a RESTful API offering two primary services, collections and channels, to support threat intelligence sharing models. TAXI services include the following: the inbox service. It is used by a taxi client to push information to a taxi server. The poll service. It is used by a taxi client to request information from a taxi server. The collection management service. It is used by a taxi client to request information about available data collections or request a subscription. The discovery service. It is used by a taxi client to discover available taxi services. MISP is an open source threat intelligence sharing platform that can be freely downloaded as an independent server or an instance. MISP offers the following features. It provides an efficient IOC and indicators database. It provides an automatic correlation of indicators with attributes. It has a built-in sharing functionality. It offers an intuitive user interface. It enables the export of threat information to multiple formats such as JSON, CSV, OpenIOC, text, or others. It provides a flexible API for customization and integration. And finally, it affords STIX support. The categories of threat intelligence are strategic, operational, and tactical. The strategic type places threat in business context and describes strategic impact informing risk management and organizational direction. The operational type is focused on adversary behavior, holistic remediation, threat hunting, purchasing decisions, and data collection. The tactical type is focused on technical indicators and behaviors to inform network level action and remediation. Now let's look closely at strategic intelligence. The primary audience of this type of intelligence are security and organizational leadership personnel. It is the who and the why of threat intelligence. So, who is behind the threat and what are their motivations? What makes the organization a vulnerable target and what can the organization do to reduce the risk? Next, we look at operational intelligence. The primary audience of this type of intelligence are threat hunters, security leadership, and incident responders. This is the how and the where of threat intelligence. It includes incident analysis, attack pattern and attribution analysis, malware analysis, and scope analysis. Next, we look at tactical intelligence. The primary audience of this type of intelligence are security operation analysts, network defenders, and incident responders. This is the what of threat intelligence and involves lowest level of information such as indicators of compromise and other observables that can provide insights to adversary TTPs. Now we look at the tools and techniques for each of the TI categories. On strategic intelligence, the tools and techniques include periodic briefing, either daily or weekly, threat sharing agreements, incident response or threat hunting plans, security policies, and system prioritization. On operational intelligence, the tools and techniques include the knowledge of adversary tools and techniques, a knowledge of vulnerabilities and currently known mitigation techniques for known threats. On tactical intelligence, the tools and techniques include adversary TTPs, a knowledge of attack vector, knowledge of indicators of compromise, systems affected, and other observables to better understand the threat.